Hey everyone, this is Nick Diribertis teaching you financial modeling. Today we're going to be doing a formal introduction to Monte Carlo simulation and the analysis of the outputs. This is part of our lecture series on Monte Carlo simulation. So we already ran through a general introduction of what Monte Carlo simulation is, why we might want to go about it, and then we kind of flip the structure on its head to first go through an example of how to do Monte Carlo simulation. Um, and I flipped it because I think it's easier to see by example um, before getting formally introduced to it, because it can sound a little bit complicated when you look at it formally, but really it's a fairly simple process, and seeing the example makes that clear. So if you haven't viewed the video on the example, go back and look at that first. So we're now looking at theoretically what is Monte Carlo simulation and what is the process. And as you look at this, if you've seen the prior videos on sensitivity analysis, you'll notice that the process here and the setup is all almost exactly the same. We have some model here. We're representing the model mathematically as we get some output. Model is some function which converts the inputs to the output, and we have multiple different inputs. Um, and in order to run these simulations, we first assign a probability distribution to each input. And then for each input, we're going to randomly pick values from their distributions. And we're going to repeat that previous step for n times. N is our number of iterations, number of simulations. And so then we're going to have all the random inputs. And then you want to calculate the model, run the model with those simulated input values. So for each simulation, you've got each random input, you pass them into the model, and you get the result. Then we want to keep the inputs associated to the outputs, so you know which inputs produced which outputs. And the final step is to visualize and analyze the results. So basically, all these last steps, or all these last three steps, are the same as sensitivity analysis, running the model with each of the inputs, keeping the model, the inputs associated with the outputs, analyzing the resulting outputs. The only thing that's different here is this random piece. So assigning a probability distribution to each input, and we're going to randomly pick the value of the input from the distribution each time that we want to run the model. So let's say now we've run the simulation, we've got our 10,000 different results from the model. Now, what can we do with those results? So there are a few outputs from the analysis and visualization that we can gather. So the first category here is probability distributions of the output. And we looked at two different ways in the prior example of how we can get at this. One is with a histogram over all the results, and then the other is with a table of the probabilities, the percentiles of the probability distribution, um, and the value of the variable at that percentile in the distribution. So in the investment returns example, that was, saying that 45% of cases we got less than $1,020, and having that for the range of different percentiles. Then we also have the probability of a certain outcome. So this, it is kind of within this idea of looking at the probability distribution of the outputs, but it's just looking at one particular point on the probability distribution. And that particular point is some goal or objective that we care about. And so we want to evaluate the probability of achieving that objective or outcome. So in our investment returns model, that was what's the chance that we're going to get the $1,050 that we need to satisfy our obligation. And then the last main output, which we haven't looked at calculating yet, and we're going to do in the next video, where we add Monte Carlo simulation to the dynamic salary retirement model, is we can look at the relationship between the inputs and the outputs. So Monte Carlo simulation, we can use similarly to sensitivity analysis, where we're trying to see what changing an input does to the model. We can get at the same kinds of questions with Monte Carlo simulation as well, trying to understand how the inputs affect the outputs. And in order to analyze this, the two main methods that we'll look at are visualizing it via a scatter plot and using a multivariate regression to get at it quantitatively. So digging into the outcome probability distributions, so you can see on the left here the kind of outputs that we had from our investment returns example. We have a histogram distribution of the full of all the outputs, all the different portfolio in values. And then we have this probability table as well as a quantitative way of showing that information. These are both getting at just the chance of having different outcomes in your model. So you can visualize this with a plot and a table, and with a plot, usually use a histogram. You can also use a KDE, kernel density estimation plot, as the other potential way to visualize this, which just gives a smoother looking output. And this helps you understand at a high level what the distribution looks like. Is it basically a normal distribution, as is the case here? What's kind of the range of the distribution? And just understanding at a high level. Are there heavy tails? Is it, non-normal, etc.? And then the probability table helps you quantify some of this and think about the chance of hitting certain values in the model. So what this probability table says is that in 25% of cases, we're going to have less than $1,020. In 50% of cases, we're going to have less than $1,039. And in 75% of cases, we're going to have less than $1,053. Um, and then I just wanted to note here that um, the value at risk is a common measure that's used in the industry, and the value at risk is typically looking at a portfolio, but it evaluates at a certain uh, confidence level or certain probability uh, the the minimum amount that you're going to lose. So it's saying like we're in 95% of days we're not going to lose more than $1,000, or yeah, in 95% of days we're going to lose less than $1,000. In those other 5% of days, it doesn't say anything about that. It could be 10,000, could be a million loss. Just that 95% of the time, the loss is going to be less than $1,000. So this probability table, um, and it actually gets at this same concept. So the probability table is actually a more general version of the value at risk measure, which probability table tells you all these different values and is general to whatever kind of output you want to look at, whereas value at risk is specifically talking about some kind of loss in your model. And usually, most commonly, to look at 90, 95, or 99% percentiles. So if you need to calculate the VAR from a Monte Carlo simulation, look no further than the probability table. There are other ways to calculate VAR in other situations, but it's getting at the same concept as this probability table. So then coming to the probability of a certain outcome. So this was where we were saying, what's the chance of getting $1,050 in our portfolio? So in order to understand how this works, let's look at a very simple example. So you have some box here, and this box has red and blue balls on the inside, and you can't see what's inside the box. You don't know how many red balls and how many blue balls there are in the box. And what you want to get is an estimate of what is the chance when I reach in to pull out a ball that I'm going to get a blue ball when I do that. Um, so, what's the process you might go through to figure this out? Well, just reach in, grab a ball. Did I get red or blue? Let me write it down. Put it back in, shake the box up, mix it up, whatever, so it's random, and pull another one out, write down its color, and just keep doing the same thing 1,000 times. And so you get a blue ball 350 out of the 1,000 times. So then what is your probability of getting a blue ball? And so a decent amount of people will probably just kind of intuitively understand this and say, well, that's 35% chance of getting a blue ball. But how do we get there? So we can estimate the probability of some outcome by basically trying a bunch of times and seeing how many of those times we achieve the objective that we want. And you just divide the number of times you hit the objective by the total number of times. And that's going to be an estimate of the probability of achieving that objective. So in the ball situation, 350 blue balls. Um, whenever we draw a blue ball, that's meeting our objective of getting a blue ball. Whenever we draw a red ball, that's not meeting that objective, and so it doesn't enter into the numerator. So we get 350 times where the trial was successful. We pulled a blue ball, and so that's the numerator. And we had 1,000 times that we pulled balls in total, and so that's the denominator. And so we get that 35% estimate of the probability of getting a blue ball. And when we applied this in the investment example, it was the same exact logic. It may have looked a little bit complicated what we did in Pandas, but all that we did was convert it into this kind of format where we assigned a 1 or a 0 based on whether we met the objective. If we got at least $1,050, it became a 1. If we got less than that, then it became a 0. So that's the same as here. When we get a blue ball, we make it 1. And when we get a red ball, we make it 0. And then sum it all up. And that's going to be just the count of how many times that you got the blue ball, or just the count of how many times that we got $1,050. So then that's the numerator, and the denominator is just the total number of trials, number of simulations, and that, taking the sum of all of that divided by the count, that is an average, right? So really, it's just getting a 1 for the positive outcome, a 0 for the negative outcome, and then taking the average of that, and that will give you an estimate of the probability of achieving the objective that you desire. So that's a formal introduction to Monte Carlo simulation. We're going to come back next time to discuss how we can analyze the relationship between the inputs and the outputs. So thanks for listening, and see you next time.